Hi everyone. Welcome to Algebra 1A with Mrs. Chirigno. This is the first lesson from Algebra 1, and technically the title of the lesson is The Language of Algebra. Really, this lesson is just kind of some odds and ends, mostly things that you've seen before, but to kind of get you ready for the idea of what an algebra class is all about. So we're going to kick it off with some vocabulary here, and you probably have some space in your notebooks to copy down these definitions. Now, just so you know, in video format, I probably won't pause long enough for you to write the words down completely. Remember, you do always have the option of pausing the video so that you can get these things copied down. So again, probably all three of these things are familiar concepts to you. First off is a variable, and this is what algebra is all about. A variable is a symbol. Typically we use a letter. You guys are probably used to X, but of course we can use any letter we want. Used to represent an unknown quantity. So variables are always things that we don't know, but that we want to find out. That's what we use variables to represent. Okay. Coefficient. Now this is a thing that you are familiar with, but maybe aren't familiar with the wording. Okay, when I say coefficient, that's the number that's attached to a variable. And when that number is attached, it means that it's being multiplied. So, for example, if you see something written like 3x, okay, this is a multiplication problem. This is 3 times whatever the unknown value is. The 3 is the coefficient, okay? The difference between that and a constant is a number that's not attached to a variable. And the reason it's called a constant is without that variable in there, it never changes. So if you have something like 3x plus 5, and here's a word that we haven't used yet, but these are called terms in an algebraic expression. The value of this term can change based on the value of that variable, but the value of this term will always be a 5. And so this is your constant. So there is a difference between a coefficient and a constant in an algebraic expression. So we're going to start off with just practicing how to take verbal sentences written in words, and turn them into math. All right, we're basically translating into a different language here. So if I say I have 8 pencils at Z cents per pencil, each pencil costs Z cents and I have 8 of them. My hope is by this point in your mathematical career, you'll look at that and know that it's a multiplication problem. Okay, so this would be 8 times Z, otherwise known as just 8Z. Now, I would be totally happy with this answer or this answer. Okay, what I don't want to see is this. Okay. Now, some of you are going to argue that these two things mean exactly the same thing, and I agree with you. Mathematically, these two things mean exactly the same thing, but we don't write things this way in algebra, okay? I don't want to see this. And you may think I'm just being nitpicky right now, but there are places later in this class where if you're writing things this way, your terms are not going to work together the way they should. I've seen it over and over and over again. So please get in the habit of always putting your coefficient before your variable. It's just the standard way we do things in algebra. Okay, this next one is a little trickier. Express the cost of 1 pencil if a 12-pack costs M dollars. This is one that I might want to employ a strategy where I take the unknown out, okay? So let's suppose that I didn't have a variable here. Let's suppose this said a 12-pack costs $2, okay? Well, if a 12-pack costs $2 and I want to know the cost of 1 pencil, that's the number of dollars per pencil, okay? So this is going to be a division problem. The way I have this written right here, I would take the $2 and divide it by the 12 pencils, okay? And that's going to be some decimal. I mean, it's going to be like, a certain number of cents or something like that. But sometimes this is easier to think of with a number in this place. And then you can go back and say, wait a second, that 2 isn't really real, right? We made up that 2. And so we know that our answer here would be M divided by 12. Okay, that would be the cost of 1 pencil. The thing I see that goes wrong here is people want to divide the opposite way. So setting it up this way is really, really important, that the cost of 1 pencil is the number of dollars per pencil. Okay, and so we know that that's going to be set up as a division problem. Okay, example 2. I have a basket with C pieces of candy. I give away 2 pieces to each student. If I have S students total, write an expression for the amount of candy I have remaining. All right, so I'm going to take this thing, which is in a lot of words, right? And I'm going to translate it word for word into a mathematical expression. So I'm going to say Mrs. Trigno has a basket with C pieces of candy in it. So right now I have C pieces of candy. Okay, I know for sure I can start with that. And then I'm going to give away. Well, think about what that means. Give away means I'm taking it away, right? That's subtraction. This right here is telling me I'm subtracting. 2 pieces to each student. So let's think about that in terms of like this example 1 here. If it's 2 pieces for every student, the amount that I'm giving away will be 2 times my number of students, right? And it gives me right here that I'm using S for my number of students. And that's it, because then it says write an expression for the amount of candy I have remaining. This would represent the amount of candy I have remaining. Now, whenever I get problems like this, I have students who want to make this equal to something, all right? It's just like driven into you at some point that everything has to be equal to something, and then you make up another letter or something like that. Notice that this question asks for an expression. An expression means no equal sign. So this right here is your expression. And so if you make it equal to something else, if you throw some other letter in there, you're kind of complicating it. You're throwing another variable in there when we don't really need another variable. So please pay attention to directions when it asks for an expression versus an equation. Okay? Okay, moving on. Some other algebra stuff. Go back to some elementary school stuff here, order of operations. And I refer to this as elementary school stuff, but I will tell you, there's probably many of you who don't know order of operations correctly. And I don't know where that comes from. I think it's because we're too quick to jump to acronyms for this. But probably when you think about order of operations, you think about PEMDAS, right? You've heard that before, or please excuse my dear Aunt Sally. I haven't heard that one in a while. Maybe they don't use that anymore. But the problem with this order, and this is saying parentheses, exponents, multiplication, division, addition, subtraction. We have to have a universal order for performing mathematical operations so that everybody does things the same and so that everybody comes to the same answer, right? And so this is the order that's been established, and there's good reason for it. But it's not this simple. It's not always just one after another after another. Most notably, multiplication and division technically go together, and addition and subtraction go together from left to right. So really, we shouldn't write this way. We should write it as parentheses or any sort of grouping symbol. Okay, there's lots of different grouping symbols. Exponents. Okay, we take care of all of our exponents. And then we do multiplication and division together, kind of at the same time. And same thing with addition and subtraction. And this will catch you every time you run into one of these, that multiplication doesn't necessarily have to come before division, depending on how the problem is written. Okay? Now, this is going to be counterintuitive here. You do need to know order of operations, right? Because there's a lot of places in math where you're going to have to undo order of operations, or you're not going to have access to a calculator, or you're going to be working with variables, and your calculator can't do variables for you. But if you are just straight up crunching numbers, I really strongly recommend you use your calculator to do a lot of the calculations, because it'll take care of all of that for you, and you won't have to worry about making a mistake. Okay? That being said, we're going to try example 3 by hand just to make sure we've got this under control. But I will encourage you as the year goes on to do some of the more complex calculating with a calculator. Okay, so this here is a structure that you've seen before, where I'm giving you values for a variable, you're plugging them in and evaluating. Okay, and like I said, we're going to do this by hand just to get the idea behind order of operations. So I'm going to write this out. We're replacing the x with a 4, so 3 times 4, minus 4 times y, which is 2, plus z, which is negative 1. Okay, so I just plugged all those values in. I don't have, well, I have parentheses here, and I guess I should clarify this. These parentheses are around just single numbers. So when I say start with parentheses, that really means like if inside these parentheses there was some operation. If this was like 4 plus 2 inside of here, I would do that first. If it's just parentheses around a single number like this, which is really written to make this multiplication, that's not what this is talking about. I don't have any exponents here. So this is where I'm starting, multiplication and division. And I don't have any division, so I'm just multiplying. And I'm going to go ahead and do this. 3 times 4 is 12. 4 times 2 is 8. And then this is going to stay a subtraction. Hopefully we're okay with this idea that if I'm adding a negative 1, adding a negative is really just subtracting. So I'm just going to make that a minus 1. And then since I'm left with just subtraction, I'm just going to subtract straight across. So 12 minus 8 is 4. 4 minus 1 is 3. Okay. Okay, next one gets a little more complicated. So let's see, 2 minus 4z. So I'm going to write this as 2 minus 4 times negative 1, okay, over y squared. So that would be 2 squared. Okay, a couple of things to cover here. First of all, remember when I referred to this p, technically in this acronym it stands for parentheses, but that also includes any sort of grouping. This fraction bar here, this line, this is a division problem. But when division problems are written this way, there's implied grouping, meaning this is grouped together and this is grouped together. So I do all of these calculations separately, all of these calculations separately, and then the last thing I'm going to do is that division. So even though division shows up here, that division is going to be the last thing I do after I do all of the top and all of the bottom. So when things are written with that fraction bar, it's implied that there's like a big set of parentheses around the top and a big set around the bottom. Okay? So I'm going to treat this almost like two separate problems. So up on top here, the first thing I bump into is some multiplication here. Okay? And it depends how you want to think about this. So if I think of this as just 4 times negative 1, I get negative 4, right? And so then this would become 2 minus and then a negative 4, okay? The way I would probably prefer to think about that is this is really like a negative 4 times a negative 1. And so negative 4 times negative 1 just makes a positive 4. And we know that subtracting a negative is the same thing as adding anyway. So one way or another, no matter how you come to that, you should end up with a 2 plus 4 up on top. On the bottom, all we have is an exponent to deal with, right? So 2 squared makes 4. And again, I'm not jumping in and doing any division here because this is implied grouping. This is like, this is all together and then the bottom is just a 4. So up on the top, I'm going to do 2 plus 4 and get 6. 6 over 4, and then I end up with 1.5. Okay? If you needed a calculator to do that, that's okay. But I'm hoping by the end of this year, you could do that on your own. Okay. This last problem down here, and don't worry, I will let you use a calculator for this one. This is a classic case of math intimidation. This is a big, scary word problem that usually shows up at the end of a homework assignment with all of this stuff in it that you don't necessarily understand, and it's just enough for you to look at it and go, I don't know what I'm doing, okay? But I promise you this is way easier than it seems. This is talking about physics, and chances are you don't know a whole lot about physics at this point in your educational career. You don't have to know anything about physics to be able to do this problem. This is a formula problem. So right off the bat, it gives me this formula. And I have no idea where this comes from. I have no idea what it means. But in math, we can work with formulas if they give us a formula. From there, all these big scary words are just talking about what these letters represent. So I see that distance is d. Okay, that makes sense to me. Time is t. And g is acceleration due to gravity. Okay, so all of those next few big scary words are just telling me what all of those letters mean. Okay? And then somewhere in the problem, I'm guessing they're going to give me values for at least some of these variables and ask me to plug them in, okay? So right off the bat here, I have g equals 9.8. And I'm going to come back to this in just a second because I know this might throw you too. But so right here, I know g is going to be equal to 9.8. And then I have 5 seconds. Now that sounds like a time to me, so that's my t. And the question is how far, which means I'm trying to find what d is equal to. So when you're presented with one of these problems that looks intimidating, okay, a problem on your homework assignment that you don't know what to do with, dive into it this way. Find yourself a formula, find what the letters represent, find what values they're giving you. And then it doesn't matter if you understand what's going on in the big picture. You can plug numbers into a formula. That's all this question is asking you to do. Okay? Now, let's go back to this guy because this throws everybody off here. This thing here, this is meters per second squared. Okay? That is a unit on 9.8. That is how we're measuring that acceleration due to gravity. You don't know that yet because you haven't taken physics yet, and that's okay. You don't know what this unit really represents. But this is the same thing as saying like 9.8 cats, okay? Or 9.8 inches. This is just a unit. This does not go into your problem mathematically in any way, okay? And even the fact that this has a square in it, everyone wants to use that square for something. That doesn't have anything to do with the problem mathematically. The 9.8 is the only thing you're going to care about, okay? So I'm going to take my formula, d, because I know that's what I'm trying to find, right? 1/2. I'm going to plug in my g value of 9.8. And I'm going to plug in my t value of 5. And I'm going to make sure I square it. So this is sort of what I was talking about. This is not a problem I would expect you to do by hand, okay? Just with the funky decimals and things like that. I mean, I think you could handle it if you really had to, but this is one that we're going to use our calculator for. If you're going to use your calculator, use it, okay? Use it for the entire problem in one shot. Don't try to do it in little pieces in your calculator, because if you try to do it in pieces and you don't do the pieces in the right order, you're going to get the wrong answer. So we are going to type this entire thing into our calculator in one shot. And for some of you, this may be the first time you're using one of these big fancy things. So let me get that scary stuff off the screen there. So let's talk about a couple of things you need to know on the calculator. So first of all, typing in the 1/2. This is the very first time we have to do a fraction on this calculator. And you will find that there is no fraction button on the calculator anywhere. Seems like a downgrade because when you used scientific calculators last year, they had a fraction button. But the people who make these calculators assume that by the time you're at the level of math where you're using one of these guys, you understand that a fraction is really just a division problem. So 1/2 can be typed in as just 1 divided by 2. Okay, that's your fraction, 1/2. And then I'm going to multiply by 9.8. And then I'm going to multiply by 5. And then here's where I'm going to push to square that 5. And there's my answer, 122.5. And let's make sure we know the right unit on that. That's our value for d, and it tells me that d, I guess it doesn't say here in the problem, it should. The fact that this is in meters means that my distance is being measured in meters as well. Sorry, that was probably a typo in writing up that problem. Okay. Okay, so that's it for your brief introduction into algebra. All of those concepts are going to show up in your assignment today.